Hello. In this video, we will do some examples involving oral medications involving liquid medications. So it's all about oral medication and liquid medication for this video. And it's just exactly the same process. You just have to be careful with the wordings. Um, so let's start with example one. Okay. Whoops. Example one says, so if I mispronounce these words because I'm not an RN or a physician, so I may mispronounce these words, but I'll do my best. So example one, you have an order of 240 milligrams mg of acetaminophen of Q6H. And our availability is acetam acetaminophen of 160 milligrams per 5 milliliters in a 473 milliliter bottle. Okay, so the question says, how many milliliters per dose round to the nearest 10? So we can do the same process, the dimensional analysis. So how do we start with the dimensional analysis? It's like chemistry stoichiometry. So you start with 240 milligrams, right? And we want to know, so the question says, how many milliliters? So our final unit shall be in milliliters. So I'm going to do times and then fraction, and then I'm going to have to put, so ask yourself, do we have to do a double conversion? I don't think so. Because we have an availability of 160 milligrams per 5 milliliters. So I don't think there isn't two conversions. So I'm going to put milligrams on the bottom and then milliliters on the top, right? And we said that we would give availability is 160 milligrams per 5 milliliters. Okay, so that was given. And is that it? No, yeah, that's it. Because our final units will be in milligrams. Okay. So as you can see, the milligrams disappear, and then you're left with milliliters. So you're multiplying fractions, so you multiply across, so it's going to be 240 times 5. And then on the bottom, it's 160, right? And when you do the algebra, you get 7.5. It says round to the nearest. And it's exactly 7.5. So I don't have to round to the nearest. This is the tens. I don't have to look at the neighbor. So this is my final answer. Okay. So that was dimensional analysis, ratio and proportion. Okay. So that's where you make the two fractions. And you can set it up any way you like. So we should set it up. You can put milligrams here and milliliters on the bottom. But if you do that, this has to be milligrams and milliliters. So ask yourself, do we need to do a double conversion? No, because we have it already in milligrams. So our availability was 160 milligrams for 5 milliliters. And then we are asking how many milliliters, so that's our unknown. So you put an X under NL. And then we had 240 mg. Yeah, that's our order, right? And then you cross multiply. So that's going to be 5 times 240 equals to X times 160. So it's going to be 160X equals to 500. I mean, 5 times 240 is 1200. Solve for X by dividing both sides by 160. And you get exactly 7.5 milliliters. Okay. Wait, hold on a second. Okay. Okay, much better. So now let's do the same problem using the formula method. Okay, so formula is desire over half times vehicle, right? So what was it? Our desire was, so make sure the desire and have must have be in the same unit. If you don't, you have to do a double conversion, right? So yeah, desire and have are both in mg, so we're good. So our desire was 240. Our have was 160 milligrams. And then our vehicle was 5 milliliters. So we're multiplying fractions, so you multiply across, as you can see, the milligrams disappears, and you're left with milliliters, and then you multiply across, that is fractions, so 240 times 5 over 160 times 1. And we get 7.5 milliliters. Okay, so that's your answer. B. So part B says how many milliliters per day round to the nearest tenth. So you kind of have to so if you go back to the problem, it says Q6. It was like Q6H, right? It was like on the problem it had a Q6H. So what that means is you're getting medication every 6 hours. Right? This Q6H means you're getting medication every 6 hours, and there's 24 hours in a day. So 24 divided by 6 gives you, so you're doing 4 times a day, and then we were given our medication was 7.5, so 7.5 milliliters times it by 4 be 30 milliliters. So in total, you're distributing 30 milliliters per day. Okay. There's a part C. So it says how many full doses in a bottle. So in a bottle, there's so in a bottle, there's 473 milliliters in a bottle, and each dose is 7.5 milliliters. So that's going to be 473 milliliters over 7.5 milliliters, and that gives you 63.07. So you can only give full doses, right? You can't give like a 0.07. So you can only full doses round to the nearest dose. So it's going to be 63 full dose. Let's do example two. So example two says your patient is receiving lac lactulose 30 milliliters TID, which means 3 times a day, for hepatic uh, hepatic encephalopathy. Lactose of 10 grams per 15 milliliter is availability. So question A says, how many grams is your patient receiving with each dose? So our final unit should be in grams. So let's start with dimensional analysis. So we have 30 milliliters. That's our, so we started out with 30 milliliters, and then our availability was 10 grams per 15 milliliters. Do we need to do a double conversion? No, because already it's already in milliliters, so we don't have to do a conversion. We do a double conversion, so you put milliliters on the bottom and grams on the top, and that's it, because we want to know how many grams, so that's good. So it was given, let's see, 10 grams for 15 milliliters. And then if you multiply across 30 times 10, so wait, the units disappears, and then it's 30 times 10, until 1 times 15. That's going to be 300 over 15. So that is going to be 20. Okay, so that's your answer. Okay, let's do ratio and proportion. So fraction. And then you consider, we don't have to do a double conversion because we already have it in milliliters. So you can put grams on the top, milliliters on the bottom, grams on the top, milliliters on the bottom, right? So let's see. We were given 10 grams or 15 milliliters, that was given. And we want to know how many grams our unknown will be X grams. And we were also given, we started out with 30 milliliters. So this is availability. This is what started out with. I know our grams is unknown. So cross multiply. So it's going to be 15x equals to 10 times 30. That's 15x. 10 times 30 is 300. That's going to be 20 grams. Part B, how many grams is your patient receiving per day? So per day, um, so he said it was given 3 times a day. TID stands for 3 times a day. So we have 20 grams times it by 3. So that's going to be 60 grams, a total of 60 grams a day. Okay. Question 3A, your patient, so this is still part of 3A. So your patient has an order for cyma- cyanotidine hydrochloride of 750 milligrams POH. How many milliliters do you administer per dose? Round to the nearest 10. How many milliliters are that are finally shall be in units? I mean milliliters. Uh, round to the nearest 10. So let's start with dimension around this. So we have 750 milligrams, right? And we're going to times it, fraction, put milligrams on the bottom, and then milliliters on top. So on this one, yeah, so I think this one, there was supposed to be a label, but the availability was 5 milliliters over three for 300 milligrams. That's supposed to be given. And then the milligrams disappears, and then multiply across, so 750 times 5, and then 1 times 700. And that gives you 12.5. So fraction, third division, proportion, just set it up with this. And let's see, we have milligrams, milliliters on the bottom, milligrams here, and milligrams at the bottom. There's no double conversion because everything is in milligrams and milliliters. So we have 300 milligrams of 5 milliliters, and then that's our availability, right? That was supposed to be given. So for 5 milliliters, there's 300 milligrams, and then we were given 750 milligrams. We want to know how many milliliters, so that's our unknown. So cross multiply. So it's going to be 300x equals to 5 times 750. And that's going to be 3750 x minus 500. You get 1.5. Right, let's do the formula method. So desire over have times vehicle, and remember desire and have must have to be in the same units. If not, you gotta do a conversion. So our desire was 750 milligrams, and we were given 300. And vehicle was the 5 milliliters. So the milligrams disappears, multiply across, so 750 times 5 is 300. And that gives me 0.5 milliliters. So question 4, down to 4. So the question 4 says your patient has an order of 2 teaspoons of codeine Glyphosine, POQ4H, codeine glyphosine oral solution is available in 10 to 100 milligrams per 5 milliliters. How many milliliters do you administer per dose? Okay, so our final unit should be in milliliters. So let's start with dimensional analysis. So we were given, we have an order of 2 teaspoons, so that's what we start with, 2 teaspoons times fraction, and then our final answer should be in milliliters, so you have to put TSP on the bottom and milliliters. So what's the relationship between teaspoons and milliliters? For 1 teaspoon, there's going to be 5 milliliters. Okay, so the teaspoon disappears, so we're left with 2 times 5 over 1. And this is going to be 2 times 5 is 10 milliliters. Okay, ratio proportion. So set it as a fraction. Let's see, you put TSP on the top, milliliters on the bottom, then this would have to be TSP on the top and milliliters on the bottom. So for 1 teaspoon, there's 5 milliliters, and then for 2 teaspoons, um, we want we want to know how many milliliters are there in 2 teaspoon. So our milliliters will be unknown, our x. Cross multiply, so that's going to be 5 times 2 equals to x. That gives me 10 equals to x. Or 10 milliliters. Okay, so question, there's a part B for what example 4. So part B says you have an order for 2 teaspoons of codeine plus codeine, uh, but I can't read it. I mean, I can't pronounce it. Your patient has an order for 2 teaspoons of codeine guaifenesin, a POQ4H. Codeine guaifenisin's oral solution is available in 10 to 100 milligrams per 5 milliliters. How many milliliters do you administer per day around to the nearest tenth? So 10 milliliters are administered per dose. Frequency is so the Q4H means 6 times per day. So here, let me write this down. So they want to know how many milliliters do you administer per day. So we have 10 milliliters are administered per dose. The frequency is Q4H, which means which is 6 times per day. So 10 milliliters times 6 is 60 milliliters in a day. Okay.
Example 5A. Your patient has an order for iso isoniazid of 0.3 grams PO once daily. Isoniazid is so availability for isoniazid is 15 milligrams per 5 milliliter is availability. How many milliliters do you administer per dose? Round to the nearest 10. So your final unit shall be in milliliters. So let's do dimensional analysis, round to the nearest tens. So dimensional analysis, we have 0.3 grams times, and then you could put grams on the bottom. Oh, looks like we got to do a double conversion, right? Because our final answer has to be in how many milliliters? So yeah, we have to do two conversions. So we do have to put grams here, and then you do have to put milligrams. And then we want to get rid of that in milligrams. So we're going to put the milligrams down here, and we want our final units to be in milliliters. So you put milliliters here. Next, put a one here if you want. What is the relationship between grams and milligrams? So according to your chart, 1 gram, there is for 1 gram, there's exactly 1,000 milligrams. And then our availability that was given 5 milliliters for 50 milligrams. Okay. As you can see, the grams disappears, the milligrams disappears, and you're left with milliliters. So multiply across. So it's 0. Not crisscross, but across cross. So 0.3 times 1,000 times it by 5, then over 1 times 1 times 50. And that's going to be 1,500 over 50. So I have 30 milliliters. Okay. Step 2, ratio and proportion. So let's see. So we do kind of have to convert, do got to convert the grams to milligrams. So we want to convert the grams to milligrams. So 0.3 grams times grams and then milligrams. So for 1 gram, there's 1,000. That's going to be 300. Okay. Now we can set it up as a ratio. Let's see here. You could put milligrams on the top, milliliters on the bottom, milligrams on the top, milliliters on the bottom. So our val said that there was our availability was 50 milligrams for 5 milliliters, and then this is going to be 300. We started out with 300, right? This is our availability. We want to know how many milliliters, so that's our unknown. Cross multiply, so it's going to be dx equals to 5 times 300. So 5 times 300 is 1,500. And then divide this by 50. We get x equals 30 milliliters. Okay, so formula, you have desire over have times vehicle. So desire and have must have the same units. So our desire was three. Well, originally we had originally we started out with 0.3 grams, but if we convert that to milligrams, that's 300 milligrams. and our half is we have 50 milligrams, and our vehicle is 5 milliliters. Okay. Milligrams disappears, and then you're left with milliliters, so that's going to be 30 milliliters. Okay, example 6A says your patient is receiving diphenhydramine HCl of 10 milliliters of POQ6H diphenhydramine HCl. Availability is 12.5 milligrams per 5 milliliters. Is available. How many milligrams is your patient receiving per dose? Round to the nearest tens. So how many milligrams? So our final answer has to be milligrams. So do we have to do a double conversion? I don't think so. So let's start with dimensionality. So we started out with 10 milliliters times fraction, and then milliliters on the bottom, milligrams on top. So our availability was 5 milliliters or 12.5 milligrams. And the multiplied process will be 10 times 12.5 over 1 times 5. So that's going to be 125 over 5. So that's going to be 25 milligrams. Okay, ratio and proportion, we're going to set it up as a fraction. So you can put milligrams on the top, milliliters on the bottom, milligrams on the top, milliliters on the bottom. So availability was 12.5 milligrams with 5 milliliters, and then it's X. We don't know how many milligrams, but you know that uh, yeah. So we have 10 milliliters. That was what we started with. This is our availability, right? And this is availability. This is what we have. The 10 milliliters what we started. Milligrams is our unknown. Cross multiply. So that's going to be 5x equals to 12.5 times 10. That's going to be 5x equals to 125. Divide this by 5, and you get 25. So let's start with the so formula is desire have times B. Okay, so our desire was 10 milliliters or 5 milliliters. And our vehicle was 12.5 kilograms. So the milliliters disappear, so you're left with 10 times 12.5 Five, get 125 for 5. So that is going to be 25 milligrams. 6B. How many milligrams is your patient receiving per day round to the nearest tenth? So our frequency was, so wait, so we know 25 milligrams are administered per dose, and our frequency was Q6H, which means 4 times a day. So 25 times by 4 gives you 100 milligrams a day. For a total of 100 milligrams in a day. Example 7A. Your patient has an order for metoclopramide 10 mg/po 30 minutes before meal tablets HS for 2 weeks. Metoclopramide of 5 mg or 5 milliliter is available. How many milliliters do you administer per dose around to the nearest 10? So our final unit shall be in milliliters. So let's start with dimensional analysis. So let's start with 10 milligrams. Our availability was 5 milliliters per 5 milligrams. So there was no conversion because the milligrams disappears and then the milliliters is on top. So for 5 milligrams disappears and then you're left with milliliters. So this works out fine. 10 times 5. And that'll give me 50. No, 10. Or 10 times 5 over 5 at 5 disappears. So you're left with 10 milliliters. Okay, ratio proportion. I don't think we have to do double converting because yeah, so we put milligrams on top, milliliters on the bottom. But this would have to be milligrams and then milliliters on the bottom, right? So our availability was 5 milligrams or 5 milliliters. We were started with 10 milligrams, and our unknown was we wanted how many milliliters, so that's our unknown. So cross multiply, so that's 5x equals to 5 times 10. 5 times 10 is 50, divided, and then you got divides by 5, you get x equals 10 milliliters. Okay, let's do the formula method. So it is desire have times vehicle. Okay, so our desire was 10 milligrams. Our have was 5 milligrams. Right? That was 5 milligrams was given. Our vehicle was 5 milliliters. So it's going to be 10 times 5 over 5, which is 50 over 5, just 10 milliliters. Question 7B, how many teaspoons do you administer per dose round to the nearest 10? So now they're asking how many teaspoons. So this one you got to do a double conversion. So it's the same problem, but they want to know teaspoon. They want it in teaspoons. Part A, they want it in milliliters. So yeah, double conversion. So let's do that. So we'll start with dimensional analysis. We started out with 10 milliliters, and then you got to get rid of the milliliters, so you put milliliters on the bottom. And oh, no, I don't think it's a double conversion. It's just teaspoon on top. What's the relationship between teaspoons and milliliters? That's something you should have known. Should know on your based on your chart. Well, according to the chart, for 1 teaspoon, there's 5 milliliters. Okay. And then the milliliters disappears, and then it's 10 times 5. Oops, not 10 times 5. It's 10 times 1, and then 1 times 5, which is going to be 2 teaspoons. Okay. Racial proportion, so you can set it up like this. There's no double conversion, so you could put teaspoon on the top, milliliters on the bottom, and then this one has to be teaspoons on the top, milliliters on the bottom. So for 1 teaspoon, there's 5 milliliters. That's something you should know. And then you want to know how many teaspoons, so that's X. And then we started out with 10 milliliters. Cross multiply, so it's going to be 5x equals to 1 times 10. So it's 5x equals to 10 divided by 5. Oops, you get 2 TSP. Okay, formula. So the formula is desire over half times variable. So my desire is 10 milliliters, and our half was 5 milliliters, right? This was available, 5 milliliters was given, available, and then you want to know how many are there, how many teaspoons are there in 10 milliliters, and their available is 1 teaspoon. Okay, put it all together, you get 10 times 1 equals 5, which is 2 TSP. Okay. Yeah. Example A, your patient is receiving ibuprofen, I've heard of that, 7.5 milliliters of POQ6H, PRN fever, ibuprofen of 100 milligrams per 5 milliliter is available. How many milligrams is your patient receiving with each? How many how many milligrams is your patient receiving with each dose round to the nearest tenths? So let's start with dimension panels. So our final answer, how many milligrams? So I don't think there's a double conversion. So we start with 7.5 milliliters times fraction, and then milliliters on the bottom, and then milligrams on the top. So for 5, our availability was 100 milligrams for 5 milliliters. Come that nicely. Milliliters disappears, and then you're left with 100 times by 1.5. That's going to be 750 per 5. which is 150 milligrams. Okay, ratio and proportion. So ratios is going to be milligrams on the top, milliliters on the bottom, milligrams on the top, milliliters on the bottom. For 100 milligrams, there's 5 milliliters. And then for X, that's 7.5. Cross multiply, this is going to be 5x equals 100 times 7.5. It's going to be 5x, and 100 times 7.5 is 750. Divide this by 5, I get 150 milligrams. Okay, so formula is desire, then we have and by equal. So our desire was 7.5 milliliters. And I have was 5 milliliters. Our vehicle was 100 milligrams. Milliliters is zero, so it's 7.5 times 500. And that goes to 100. Example 9. Example 9 says, your patient is receiving promethazine hydrochloride and that's bromethylphen hydrobromide oral solution of 5 milliliters every 4 to 6 hours or PRN on. How many teaspoons do you administer per dose randomly minutes 10? So this is a trick question. Drug strength doesn't matter for this problem, just convert milliliters to teaspoons. So yeah, but this one's a bit tricky. I mean, trick question, not tricky. So drug strength does not matter for this problem, just convert milliliters to TSP. So 5 milliliters is equal to 1 TSP. So your answer is 1 teaspoon of TSP will be used. Question and B, what is the maximum number of milliliters a patient may receive in a day, down to the most ton? So, so we have 5 milliliters every 4 to 6 hours. So it's just basically 5 milliliters times 6, which is 30 milliliters. in a day. That's right. It's question 10. Question 10 says you have a patient, your patient has an order for cetri- cetirizine 10 mg keto once daily. Cetrizine 1 milligram or 1 milliliter is available. How many milliliters do you administer per dose? Round to the nearest tens. So our final answer has to be milliliters. I, yeah, this one is pretty simple. Let's start with dimensional. So it's going to be start out with 10 milligrams times, and then you put milligrams in the bottom and then milliliters in the top. So for 1 milliliter, there's 1 milligram. That's going to be 10 times 1 equal 1. That's going to be 10. So ratio to proportion. So milligrams in the top, 5 milligrams, milligram. So for 1 milligram, there's 1 milligram, 10 milligrams. It's milliliters, plus y, that's 10. That's 0 up to 10 milligrams. The formula method is it's desired, never have. So dissolve was 10 milligrams. We were given the one, and then it was 1 milliliter. So put it all together, you get 10 milligrams. Question 11. Your patient has an order for prednisone sodium phosphate of 37.5 milligram mgpo once daily. How many milliliters do you administer per dose, not to the nearest 10? So how many milliliters? So if I answer is milliliters, so I don't think we do a double converting. So let's start with dimensional. So we start with uh 47.5 milligrams fraction, and then I guess you put milligrams in this one and milliliters in this one. So for 5 milliliters, there's 25 milligrams. I don't know one there, but the milligrams disappears, so I have to go 37.5 multiplied by 5, and then 1 times 25. So that is 1.7. So that's to be so 5 milliliters. Not doing those 10, so yeah, you're good. Ratio and portion. So it's going to be fraction. I need to put milligram on the top, no bottom. and then this is milligrams. So availability was 25 milligrams for 5 milliliters. We want to know how many milliliters, that's what I know, for 37 milliliters. Cross multiply, so it's 5 times 5 equals to 25x divided by 25, and you get 75. Formula is desired over half times big. So a desire is 37.5 milligrams. I have is 25 milligrams times 5 milliliters. So you get 7.5 milliliters. Question 12. Example 12 repeating as an order for methyl bromide hydrochloride. Hydrochloride 24 mg/kg in two equally divided doses daily 30 minutes before a meal. Methyl benadate hydrochloride 10 milligrams per 5 milliliters is available. How many milligrams to administer per dose round to the next tablets? So we're trying to figure out how many milliliters. How many, no, not milliliters. How many milligrams? So this one's a, it's actually a trick question. Not not it's not a trick, it's like a, so we know there's 24 mg and it's divided into two doses, two equally divided doses. So it's just 24 over 2, which is 12 mg. Okay, 12B. How many milliliters do you administer per dose round to the nearest 10? So this is built, this is part of 12A. So 12B says how many milliliters do you administer per dose round to the nearest 10? So let's start with dimensional analysis. So we started out with 12 mg, and then you know that availability is 5 milliliters for 10 milligrams. That was given. That's our availability. And then the milligrams disappear. So in our final answer is milliliters, so that's how much weight. So 12 times 5, and then 1 times 10. That gives me 6 milliliters. Okay, ratio and proportion. So mg here, milliliters at the bottom, here, bottom. So for 10 milligrams, it's 5 milliliters. And then I just remember how you talk milligrams other numbers. Plus multipliers, that's giving me 10x. So 12 times 5, and 5 times 12. So that's 10x equals 16. X equals 6 milliliters. Okay, formula, so it's going to be desired, never have, times with So our desire was 12 mg. We had 10 milligrams, and then that was 5 milliliters, and 1 to 6 milliliters. Okay, a few more. Wait, Sample 13. Your patient is receiving dextromethorphan syrup, 2 teaspoons every 6 hours. This medication is available in 6 ounce bottle. How many milliliters do you administer per dose round to the nearest 10? So we want to convert it to milliliters. So let's start with the HMI. So let's start with 2 TSV. Sorry, I'm tired. Okay. So yeah, you're starting with 2 TSP times TSP on the bottom and then milliliters at the top, right? So we know that for 1 teaspoon, there's 5 milliliters that was given. And then just multiply across like 2. So it's going to be 2 times 5 over 1, and then give me 10 milliliters. Okay, ratio and proportion. So you could put TSP on the top, milliliters on the bottom, TSP on the top, and milliliters on the bottom. So for 1 teaspoon, there's 5 milliliters, and then for 2 teaspoons, we want to know how many milliliters are there in 2 teaspoons. So that's our amount. Cross multiply, so that's going to be 5 times 2. What's the x? So that's going to be 10. What about 13B? Did I skip it? Oh, okay. Oh, we did 13B down. Okay, let's move on to 14. Okay, so 14 says your patient is receiving Y difloxacin syrup of 10 milliliters every 2 hours for a time. This medication is available in a 4 ounce bottle. How many teaspoons do you administer per dose round to the nearest tens? So our final answer has to be in teaspoons. So let's start with dimensional analysis. So this is something you need to know. You must know from the chart. So you must know 1 teaspoon is 5 milliliters. Okay, that's something you should know. So 10 milliliters times milliliters on the bottom, teaspoon on the top. So for 1 teaspoon, there's 5 milliliters. milliliters disappear, so that's gonna be 10 times 1 with 5. That gives you 2 TSP. Ratio and proportion, so fraction. You could put you could put TSP on the top and milliliters on the bottom, and this would be TSP and then milliliters. So for 1 teaspoon, there's 5 milliliters, and we want to know how many teaspoons are there in 10 milliliters. Cross multiply, that's going to be 5x equals to 1 times 10. So that's going to be 5x equals to 10 divided by 5, get x equals 2. Fourteen B says, how many full doses are in this bottle? So how many full doses are there in this bottle? So let's start with dimensional analysis. So this is something you must know. You must know based on the chart, 1 ounce is equal to 30 milliliters. Okay, it's something you should know. So let's start with dimensional analysis. So start out with 4 ounces, and then you can put ounce on the bottom, milliliters on top. But we just said that for 1 ounce, there's 30 milliliters. The ounce disappears. We're left with 4 times 30 divided by, which is 120 milliliters. Wow. Well, that's pretty equal to 12 bases. Okay, let's do ratio and proportion. So you can put counts on top, milliliters on the bottom, onto the top, milliliters on the bottom. We know that for 1 ounce, there's 30 milliliters. And this is 4 ounce. And R on those milliliters, plus multiplies x equals 30 times 4, which is 120. 120 milliliters in a bottle. And then divided by 10 milliliters per dose. So that's how about 12 doses. For 15A, your patient is receiving diphenhydramine hydrochloride solution of 20 milliliters of Q6H for allergies. Diphenhydramine hydrochloride solution availability is 12.5 milligrams per 5 milliliters is available in a 4 ounce bottle. How many mg do you administer per dose round to the nearest tenths? So let's start with dimensional analysis. So you're left with 20 milliliters times milliliters on the bottom and mg on the top. So availability was given 12.5 mg for 5 milliliters, and then a 1 here. So the ml disappears. So you're left with 20 times 12.5. And then on the bottom, it's 1 times 5. So that's 250 over 5, just 50 mg. Right, ratio and proportion. Let's see, but I mean, ml here, mg here, ml here, mg there. So 5 milliliters or 12.5 milligram mg. We want to know how many mg are there in 20 milliliters. Cross multiply, that's going to be 20 times 5. It's 5x. 20 times 12.5 is 250. 5x divided by 5. You get 58 mg. Okay. Formula. The buyer never have times vehicle. So our desire was 20 ml. Our have was 5 milliliters. And vehicle was 12.5. So that's going to be 20 times 5. 1. So that's going to be 50 mg. B says, how many full doses are in this bottle? So, so how many full doses are in this bottle? So first you gotta first find how many doses per bottle. Then you know, then divided by 20 milliliters. So let's start with dimensionalize. So we are given 4 ounces times fraction, and then ounce in the bottom, milliliters in the top. So for 1 ounce, there's 30 milliliters. So that's going to be 4 times 30 over 1, which is 120 milliliters in a bottle. Okay, and then what we have to do is divide that by 20 milliliters per dose. So that gives us 6 doses. Yeah, so we need to know this one right here that this is something you should know. You should know 1 ounce is 30 milliliters. Okay, ratio and proportion. Okay, so write it out the fraction. So ounce in the top, milliliters on the bottom, ounce in the top, milliliters on the bottom. So we know that for 1 ounce, there's 30 milliliters, and for 4 ounce, we want to know how many milliliters are there in a milliliter in 4 ounces. So cross multiply, that's going to be x equals 30 times 4. That is going to be 120 milliliters. And then, so this is 120 in a bottle. Then you divide it by 20 milliliters per dose. So that's how you get 6 doses. Okay, I think this is the last one. So 16. Your patient has an order. Your patient has an order for flubenzyme hydrochloride 8 mg Q8 Q8H. Fluben, flubenzine, flubenazine hydrochloride availability is 0.5 milligram per 5 milliliters is available in a 60 milliliter bottles. How many milliliters do you administer per dose round to the nearest tenths? So the final unit is in milliliters. So let's start with dimensional analysis. Okay, so we have 8 mg times and then fraction and then mg bottom and milliliters on top. So for 1 milliliter, so 0.5 mg. And that's multiply 8 times 1, and it's 1 times 0.5. So it's going to be 16 milliliters. Okay, ratio proportion. Give it mg here, milliliters on top, mg here, and milliliters on top. So we're given 0.5 mg for 1 milliliter, or 8 mg. You want to know how many milliliters are in the mg? Cross multiply, that's 8 equals to 0.5x. Divide this by 0.5, 0.5, you get 16 milliliters. Okay, the formula method is our desire was our desire was 8 mg over 0.5 mg times by 1 milliliter. So that's going to be 16 milliliters. Okay, 16b says how many milliliters do you administer per day round to the nearest tenth? So you need to know that Q8H means 3 times per day. So 16 milliliters times by 3 is 48 milliliters a day. Okay, okay, we can stop here.